Hello, I'm Zachary Kersey, and I am here to present my Sociotechnical research on both my thesis and my capstone. So, a summary of my work. There was a common theme of my work of using advanced technology solutions to solve age-old problems in various sectors in our country. The first, which is my capstone, is using machine learning to improve the additive manufacturing industry to be able to detect dross in real time, dross being a metallurgical defect in a part printed. And my thesis is the exploration of how we can implement a blockchain-based smart contract into derivative finance to decrease transaction costs, shift the power to the retail investor, and open up investing for the common person more so than already is. I will start with my technical thesis first. Like I said, this was a capstone project completed as part of the systems engineering requirement with a group of people. Our group was mixed between computer science majors and system engineering majors, which helped us tackle this problem to the best of our ability. So, a quick overview: additive manufacturing, which I mentioned before, more colloquially known as 3D printing, is the use of a 3D printer to build up more advanced metal parts, such as airplane turbines or small parts used in machinery in a hospital, or other various things that are traditionally used via casting. So we worked with CCAM, which is the Commonwealth Center for Additive Manufacturing. They're located in Petersburg, Virginia, and they're made up of, as a cooperative of universities, industry sponsors, and academic researchers who are attempting to improve various advanced manufacturing processes, AM being one of them. So, like I mentioned before, dross is a solid impurity that forms on the surface of metal parts during additive manufacturing, and it compromises the part structure and also ensures that every part is unique, which is not desirable in an iterative design process. So our goal for this capstone project was to develop a model based on machine learning techniques that can accomplish the real-time detection of dross during printing and help improve costs and efficiency of the currently extremely expensive and inefficient additive manufacturing process. So we first started the problem by printing out a part and figuring out what part geometry, environmental printing conditions, and printer errors cause the most dross. We were able to come up with a part that is extremely drossy, both visually and from the images we took of it, which allowed us to analyze various parts of the image and figure out what dross looks like in the image versus on the part. So with the images, we used a high-resolution infrared camera located inside the M290 EOS printer that we were using to develop a series of about 3,000 images of each layer of the part that we printed. We then kind of compared the layers with the part that we actually printed, which we had in our physical possession, to figure out what slice of layers we will train our data on, trying to look for a place of the part that's both drossy and not drossy. We then ran these images after labeling them manually, which took a long time, through a convoluted neural network based on machine learning techniques to analyze the images and detect dross using bounding box segmentation. So in our model, it was pretty successful. We had 83% recall, which was 13% above what our client requested of 70%, and then with a 60% precision metric, which means that we were having more true positives than false positives. We won Best Paper at Seeds for our work, and we are very proud of our model that we produced. On to the next problem that I tackled, this one more individually as my thesis. A quick overview of the problem that I talked about prior, which is the using blockchain and derivative finance to increase accessibility and increase transparency in the financial space. Derivative contracts are a type of financial instrument that are tied to the value of an underlying asset. For example, a corn future, which is being able to buy corn at a later time at today's price, or a option to buy Facebook at a certain price at a later time, a share of Facebook. They're way more complex in execution than a simple stock or bond, and they've always kind of been known as being opaque and less accessible with higher transaction costs, and also, more recently, one of the biggest causes of the financial crisis of 2007 and 2008. My solution that I proposed is blockchain technology, specifically Ethereum-based smart contracts. Blockchain is if you don't know, is a form of cryptographically linked records used to maintain a decentralized, immutable ledger by storing data as blocks connected by cryptographically linked chains. Smart contracts or a specific form of blockchain that use the underlying technology to develop automatically executed contracts, which can have a variety of terms from legal contracts to derivative contracts like we're exploring here, or other various contracts. So these smart contracts, I did a theoretical exploration and realized they can be utilized in the place of an exchange board. For example, the Chicago Board of Options Exchange that oversees options contract trading in the US, and that being able to replace or kind of take over to some extent an exchange board would reduce costs and create a power shift towards retail investors from banks and the governmental organizations that oversee trading to these retail investors, aka you and me, creating more decentralized, transparent markets that are more accessible for the average person and easier to avoid financial crises in the future. It has the potential to change the landscape and really make this finance more accessible for the average person. So like I said, I touched upon earlier, there's no real connection between these theses. One is a personal interest that I explored myself. The other was an assigned project that I came to appreciate, but that I worked with a bunch of other students in the interest of a client. But there is a connection in that they both leverage advanced technological solutions to help solve age-old problems in a variety of industries. So, if I had more time on these projects and where I'd want to take it, with the machine learning project with CCAM, it's a pretty easy solution. We would like to develop a model that does real time as opposed to after the fact. This would really help increase their efficiency and reduce the cost of the process more than already we helped them with. And if I were to continue my thesis exploration, I would definitely try to go for more of a prototypical system and a survey with more data collection and try to really see if there is interest for this blockchain to be implemented in derivative finance, and if there's really a place for it and what experts think and how it would be done potentially. Thank you.